Welcome to this fourth and final inspirational conference, which is a new format as part of the supply chain event, where we will indeed try to instill new ideas. So for this occasion, it is a new idea in planning methods for supply chain, which is not MRP2, which is not DDMRP, but is something else entirely, called no chain planning, and which will be presented. Afterwards, we will judge it on its merits, but it is presented as the revolution in industrial supply chains. So we will explore this with the key players who are No Chain Planning Technologies and Argonne & Co. So with us is Fabrice Bonneau, who was present at the previous inspirational conference. Fabrice Bonneau, who is the founder and partner of Argonne & Co. There is Florian Saucias, who is the managing director of No Chain Technologies, because No Chain Planning is the concept and No Chain Technologies is the solution. And then there is Jonathan Barkat, who is in charge at Argonne & Co. of the supply chain planning offering. There you go, gentlemen. I will leave you for about half an hour. Then afterwards, I think there will be quite a few questions.
We indeed hope so. So hello, everyone. It has now been several years since Argonne has invested in this subject of industrial supply chains. And when we say industrial supply chain, to be completely precise, it encompasses everything related to factory planning, everything upstream, what we call upstream. So we have been investing in this subject for a long time because we were ultimately not frustrated. But the observation is that it does not work in many places regarding these industrial planning issues. It is complex, more complex than elsewhere. There are routing, bill of materials, there are lead times, there are supplies. It is more complex than the downstream supply chain. Therefore, we have thought a lot over the years, and it is true that the context of recent years has proved us right, because the context of the industrial supply chain has become even more difficult than before. Since COVID-19, we know well that there are supply shortages, that there are many uncertainties on this upstream chain, that suppliers, unfortunately, and it is not always their fault, do not have the same service level as before, that we have problems with human resources as well, that there are new regulatory constraints that we discussed this morning, that we really need to pay attention to everything related to inventory levels, obsolescence, trying not to rely too much on express shipments, regulations, etc. So in fact, we have even more constraints on this upstream supply chain than we had before, and with ultimately tools that have not evolved much and methods that have not evolved much. And you all know it if you are a bit at the heart of these production and supply planning issues. You realize that we have unstable signals. We have... Thank you, Jonathan. We have instability. We talk about the bullwhip effect, and that reaches all the way up to production planning, where even if the demand does not change, the plans do. We wonder why, when demand changes, it does not change as quickly as we would like, because there are silos. We often lose sight of the true customer demand. So we are in the process of doing things, and we realize that ultimately demand has shifted, and it is not what we should be doing. I think we have all been there, because these value chains are a bit complex. Demand is becoming increasingly volatile. To try to explain this to you, because we say what we say, but in the end, fundamentally, why is it like this? Well, that's the way it is, because the MRP as such, the MRP you find in ERP systems, all of them, MRP is indispensable. We're not saying it's not necessary. Calculating needs, bills of materials, we are not saying it's not necessary, but MRP as such, if you keep it as it is and take it in its raw form, has a lot of drawbacks, a lot of problems, and these problems and instabilities are intrinsic to it. And Jonathan is going to give you a few didactic examples to show you why the MRP is so problematic.
Thank you. We're going to take a slightly simplified example of the MRP logic. We'll use an example from the dermocosmetics industry to illustrate its limitations. And as Fabrice said, everything we have seen in recent years, and we have seen a lot with COVID, so let's take a slightly simplified example. In MRP, we start from customer demand. So typically, we have a quantity of 1,000 jars of cream to deliver by the end of April, And as we need to deliver them to China, we have 1 month of transport. In our supply chains, we all have safety, and we need this safety to ensure customer service, to take count of unforeseen events. So we have 1 month of safety, which we have positioned in March. And so this means that we must have our packaging and the finished product that we will manufacture in February. And to manufacture this finished product, we need 1 jar, well, 1,000 jars, 1,000 cases, and above all, the cream. So here, we are really on a completely classic MRP scheme. As it works today, we start with the customer demand and then work down, calculating the routing, the bills of materials, and the sequencing, the lead times that go with it. Let's take a few examples, 4 of them, to illustrate the limits we can have today, and I think you have all encountered them in your companies. There is a delay on a case order, a supplier who is 2 weeks late, and so he passes the information on to procurement. The suppliers postpone the demand, and then we end up with a case that is late compared to requirements. Typically, we'll get an exception message in SAP saying we'll need to reschedule. But is this time lag really that important? Basically, we are 2 weeks late, and 2 weeks late just means that we will be able to manufacture the cream a little later. We will have to consume the month of safety we had planned, and in the end, there is no real impact for the customer. So what happens is that the MRP today is on-off. A 1-day delay, a 30-day delay, it's the same message, the same exception message. And a supplier or a planner will have 100 or so production orders. With our customers, we realize that between 20% and, depending on the customer, up to 40%, so roughly 30% of orders have an exception message. So if you have 30% of orders with an exception message, you're unable to find the right priority. So with this on-off side of MRP, you lose your sense of priorities. If we take a second example with the same supplier, but this time with a delay of more than 1 month, we realize that we are consuming all of the safety. We have got an unrealistic plan. And so if we ask what we're going to do as a general rule, is to say we've got an unfeasible plan. The customer isn't aware of it. And so in that case, we are unable to tell him that we will not be able to make the product. So if we're generally going to do something, i.e. reschedule production, then we'll be able to say to the customer, I'm not going to be able to deliver this cream to you. But then we end up with an effect. On the other hand, the case supplier suddenly finds himself on time in his system with no more exception messages. And the other suppliers find themselves well ahead of schedule, even though customer demand has not changed. So our priorities have changed, and we do not really know what we should be doing, and we are all hesitating. You have all hesitated to put into the system this signal of what I can do in relation to my constraints, but which at the same time no longer indicates the customer's priorities and what I must do to be able to deliver them.
And so in concrete terms, here the person who makes the case, now he is on time. So he's not going to do anything to try and be on the right time. So we have no chance of succeeding because he adjusted his scheduling. He says it's okay. He's moved ahead, and basically we're not going to deliver to the customer. And we have no chance of calling the case supplier back to try to gain a few weeks and get back on time.
And so we end up with this MRP limit where we have only one signal. Either we put what we know we can do, or we put what we must do in the MRP. I'll take a third case, a demand that moves. Unfortunately, that happens. In this case, the ramp up is much greater, the demand explodes. In fact, we need to shift demand forward. Demand is going to fluctuate while the factory is doing its production plan and planning. We're going to lose a few weeks before the factory production order is moved, and gives the information to suppliers that we're going to have to stock up the jar, the case, and even the upstream manufacturing steps, doing them much earlier. And in fact, with all this, we've lost at best a few weeks, at worst a few months, because demand has moved, but because of all these intermediate planning stages, we've lost this sequential aspect of the MRP, which means that we don't see the signal right away, and we find ourselves, and we saw a lot of this after COVID-19, when we had fairly rapid restarts with tier 2 suppliers, or even directly in the companies of tier 2 or 3 plants, which were only informed of the activity restart a few months later. And at that point, collectively, we all lost time when we could have been building capacity to serve the customer. So this sequential aspect of the MRP means that we all lose time because we don't see the customer demand when we're at the end of the chain. And so we're a little lost as to what the priorities are and what I must do once again to save the company's sales. There is one last limit to the MRP. It's its origin. It's aimed at the supply chain's key functions: load capacity, planning, and procurement. There are a certain number of related functions which contribute directly to added value and meeting deadlines, and therefore to customer service, but which are not actually included in the MRP process. We inevitably think of functions such as purchasing. For example, do I have to renew contracts? In the aeronautics industry, we can find ourselves with a large number of quality notices to process without necessarily being able to identify them. And the most urgent is usually the one from the workshop next door to the friend who's shouting a little louder, and that's the one that goes before the others, even though it's not necessarily the one that has the greatest impact on the customer. And that's the fourth limitation of MRP, which is that beyond the traditional supply chain functions, it doesn't work very well and doesn't involve all the company's functions in the same objective and the same guiding star.
In fact, we've been aware of this for many years now, as we do a lot of projects linked to industrial planning. So we thought about it and created a method, and you're going to see a tool, because we know that a method without the tools doesn't do much, and we chose to call it no chain planning on purpose. To put it simply, you're going to see it. We need to connect customers more directly to real demand and avoid the chain effect you're all familiar with. So it's really a new approach, a new concept, and a new way of doing things that doesn't replace the MRP. It's important to keep this in mind. It complements it. It's based on the information we can see, but it has an extra layer to avoid all the issues we've just seen.
The no-chain planning concept is based on two fundamental principles, which are in fact two signals that we're going to calculate and, as Fabrice said, add to the MRP information. The first principle, the first signal, is the must-do signal. What does must-do mean? It's very simple. It's the date on which, as a supplier, as a planner, I must deliver or supply my product to meet demand. And that, regardless of the intermediate stages. We take into account the milestones. Obviously, we take into account the lead times of the manufacturing stages, but that's if I want to meet the ideal demand. My customer's request, this is the date by which I must make the product available. And this allows us to do a lot. First of all, it allows all company functions to have the same date and the same priorities. The planners, the suppliers, so the suppliers are connected to customer demand. They're not connected to the first stage of production anymore. It also helps to give meaning to functions that were losing some of their meaning, typically procurement. I work in the aeronautics industry where there are 10, 15 or so levels of bill of materials, and it's hard to see the impact on the customer when the supplier is at the end of the chain. In this case, by directly connecting suppliers to customer demand, we're giving them back their priorities and a sense of what they're doing and the extent to which they add value to the company. And when we say that, it's clear that we're able to immediately calculate the impact of a change in demand on the signal, on supplies. The on-off side of the MRP is not completely resolved. In fact, the must-do signal is a little more complex than one date. It's two dates. On the one hand, there's the ideal must-do. The ideal must-do date is the date on which I must supply to serve my customer and respect all my safeties. We've said that safety is still important in a supply chain. We need to have these buffers to absorb contingencies, and so the ideal must-do is the date on which I need to meet customer demand with a margin so that the company can operate. On the other hand, there's the stock-out must-do. The stock-out must-do date is once again the date by which I must deliver my product to serve the customer, but this time having used up all of my safety. This means that if I deliver on the stock-out must-do date, I put my supply chain at risk, since all the stages after me have no room for maneuver. And above all, it means that if I deliver after the stockout must due date, I have a direct impact on my company's sales, since I'm jeopardizing customer demand. And we're able to calculate at that point what the impact will be in terms of sales, margin, whatever your indicator, and how long the delay will be. We won't necessarily give the same level of priority to a 3-day delay as to a 3-week delay. So that's really the first signal, the must-do signal, which once again synchronizes all the company's functions on the same guiding star, on the same objective. And so we all have the same priorities, which are the orders that won't be delivered and that have the greatest impact on sales. Then we're in real life. In real life, things don't necessarily go according to plan. So we'll calculate a second signal, which will come from the other side, based on what we have in stock and our components, and we'll calculate a can-do. What is the can-do? The can-do is the date on which I will be able to manufacture my product, taking into account my inventory level. We often already know how to do this in ERP systems, or at least we know how to do it on one level of the bill of materials, but we also take into account future delivery times and delivery schedules, so we're able to project what I'm going to be able to manufacture as a function of my procurement plan, and that going up all the BOM levels and typically all the SAP divisions. And so here we are with this cream. Taking into account my case delay, I'm going to be able to manufacture this cream in March for a release at the end of March. On the other hand, we also have internal constraints, maintenance, holidays, and production stops. So we can say to ourselves that if my supply chain is shut down in March, in fact, I'll be able to say that at most, I'll be able to manufacture my product in April. At that point, we'll calculate a total can-do that takes into account both my external constraints and my internal constraints. The objective with all these no-chain planning concepts is to be able to complete the MRP result by displaying both the must-do and the can-do at the same time, and by working on these two signals and these different dates to give the different teams the tools they need to make the best decisions and the same decisions at every level of the chain.
So if we look again at some of the limitations of the MRP, in the introduction we talked about an on-off MRP. That is to say, one, where we had difficulty in setting priorities. When we take this ideal must-do and stockout must-do information, we are able to have a prioritized signal. The fundamental subject of this whole concept is how I can see the impact on the customer, and this has a second effect, which is to be able to stabilize the signal. In other words, from the moment I'm directly connected to the customer's request, I avoid all the vibrations at intermediate levels. That's the first point. And as soon as I have a vision of the multi-level buffers, which are the safeties that may exist downstream of my link, I know how to react at the right level. So as soon as I know that I have consumed a tiny bit of safety, but that in any case I'm not impacting the end customer, I don't have any overreaction from the supply chain. So there's a dual objective: to set priorities, but also to stabilize the signal. The second point is that the MRP has only one signal. I think it's important to circle back on this. It is what Jonathan said earlier, that in the MRP we're always faced with a terrible dilemma, which is, do I keep the priorities? And by doing that, I don't know how to give a vision to my downstream supply chain and to my customers, or do I make a realistic plan and lose all the priorities upstream of that? All we're saying is that these two signals constantly cross every link in the chain, and one never replaces the other. And you don't have to lose the signal at some point when you set an order in the ERP. The third point is on the issue of the sequential aspect of the MRP. We're always talking about agility, flexibility, agility, flexibility. The real issue with the lack of agility in the MRP mechanism is really all these planning stages before the signal is really transmitted, with this direct connection to customer demand somewhere instantaneously, with each link knowing exactly what it has to do the day after a customer request is received, so that the whole chain can deliver to the customer. And we're not at a stage where we're passing the ball back and forth, where we're making telephone calls, which ends up losing a bit of the sense of what the customer demand really is. And the last point about the MRP logic, which ends up being a bit imperfect. When we look at delivery problems in the aeronautics industry, for example, Honestly, we're always talking about planning, load capacity, and so on. But the problem is multifactorial. It comes from procurement, quality, design department, production engineering, etc. And at some point, all these functions are often completely out. When you take a quality manager who has hundreds of quality notices in the aeronautics industry, honestly, he's completely out of this flow logic and all this customer connection logic. And the fourth point, which is fundamental, is to say that this information must also exist on quality notices. It must also exist on purchasing contracts. It must also exist on the industrialization of routing, because at some point when we run out of stock, it's not just because I had a load capacity problem.
So what we also find, as Jonathan said earlier, is that it brings meaning to the entire team. The fact of having the customer's vision. By saying, if I don't do this, I'm going to lose these sales, it finally brings the customer into the heart of the factory. In other words, we want to bring the customer into the heart of the factory. Okay, but how? Well, that's one way of doing it in an extremely concrete way and getting everyone to focus on it. So we're going to take 5-10 minutes to illustrate how these concepts work. They're wonderful concepts, but how do they work? Obviously, you need information systems, it's clear, and quite complex information systems. Because when we talk about calculating must do or can do, we're talking about tens of thousands or even hundreds of thousands of pieces of code that need to be written to perform all these calculations in the ERP. So to support these concepts, we have developed a solution called No-Chain Technologies, which supports these concepts. And it's through this solution that you're going to see illustrations of what it does in concrete terms for people. So first for managers, then for the suppliers, then for the planners, you will see 3 screens. There are about 100 screens in total, and we're not here to give you a demo. We're here to illustrate these concepts in real-life situations.
So we'll take a first example, which is a general view of the health of the supply chain. We'll take a second example on the procurement side. And it's important for us to take also the procurement side, because we're always talking about planning. And when we talk about planning, we forget procurement. And most companies must have almost 60% of their added value on the procurement side. So we talk about load capacity, finite capacity, end-to-end dashboarding, but never about procurement. And yet it's 60% of the purchased value, so it's worth dwelling on it a little. And we'll do a third use case, which is around capacity, to see how, in this method, from a load capacity point of view, we're trying to think differently from the load capacity as it's usually seen. The first example is the projected view of a company's revenue, for which we're going to try to compare the must-do with the can-do to get a view of the risks and be able to say, for example, in the second month of the year that we're going to have a turnover of 41 million euros, and to say to ourselves, in the end, how much of the turnover is at risk, how much is stretched. So we see that what is at risk is red. In other words, we're going to deliver late. And when we say we're going to deliver late, we're going to deliver almost 58 days late. And what proportion of this turnover is very tight? Delivered indirect is in yellow, in other words, just in time. And what proportion of our sales in green we're going to deliver perfectly on time, or even in inventory. To get a healthy view of this supply chain and being able to do this, so earlier we were talking about total can do, external can do. The subject is also about being able to do it quickly, being able to say to yourself, where do my constraints come from? Do they come from my internal planning, or do they come from my procurement constraints? With these two signals, we can separate them in a simple way. In this example, planification and procurement contribute almost equally. With 8 million euros each, 8 million euros out of the 19 million euros in shortages both contribute to this delay in capturing revenues. So that's the first case. And we'll try to illustrate the second case on the procurement side. A supply planner, once again, as Jonathan was saying, in all honesty, most of our customers have around 30 or 40% of exception messages in some kind of information system, M3, SAP, Oracle, whatever. And the real question is how to give them meaning, as Fabrice mentioned, and how to attach a certain number of complementary indicators so that they can prioritize the work. So on all purchase orders, on all purchase requisitions, we will obviously always have the delivery date, which everyone has here, for example, on 14 February. But there is always a quadruple set of indicators, which are the ideal must do and the stock out must do. Is that I was supposed to deliver on 28th November, so more than 3 months ago. And once again, this means a deadline by which we have used up all the safety on the central inventory stock, the safety lead times that we have been able to put on the components, and even the safety in the network. And so this means that we are having a direct impact on the customer in China. The ideal must do in green is on 24th of October, 1 month earlier, and ultimately represents all the multi-level safety that has been positioned downstream of this supplier. And as it is more than 3 months late after this stock out date alone, this order represents $3 million in sales and almost 2 months backlog. That changes everything, because at a given moment, you have a supply planner who knows his direct impact on the company's performance and unserved sales. And that's fundamental. And above all, he doesn't have to wait for the planning to be done to know that he has to work on this order, he has to reschedule it. Because in any case, a planner is going to need it, and a planner on the different levels of bills of material is going to need it. The third use case is for capacities. So before explaining the complex graph, we are used to doing a lot of planning projects, MPS, SNOPs, and so on, where we patiently try to set up processes, we try to get the right data quality, and then we try to do load capacity. And in a meeting, we'll come up with load and capacity graphs, and we'll say that we're at 105% saturation, 110%. And we realize that generally we don't take decisions. And we don't take decisions not because people are afraid or not pragmatic, but they don't take decisions because actually, does this have an impact on the end customer? We don't really know. Will demand not change in 3 weeks anyway? And in any case, the next link doesn't know how to do it. So maybe there's no point in fighting, and in the end, we don't make a decision. We're going to illustrate the concepts of no-chain planning once again by asking ourselves how we finally managed to transcribe the customer impact on a load capacity exercise. The dotted gray curve we can see is basically the cumulative capacity that a work center can have. So here we have over 6 months, about 1,600 hours, a bit more than a 208 for a machining center, for example. And we're going to come and cut out the areas. So that's the cumulative capacity, obviously. And then we're going to divide up the areas into impacts and infeasibility. If we start with the area at the very top, the gray hatched area, that means that you can put your capacities, you can increase these capacities up to that level. That's fine, but you won't have the components to feed it. In other words, it won't be very useful. You'll have put people in front of the workstation, in front of the machining center, but in any case, there won't be enough to power it. On the other side, and we can see that the curve passes through this part, the red zone, which is more or less the same meaning as what Jonathan explained in the concepts. If I position the capacity at this level, I know that as a planner, I have a direct impact on customer demand, and I have a direct impact on the loss of turnover and the increase in the backlog. And once again, just to remind you of the difference that can exist with an MRP, this is not the vision of the higher level of bill of materials, but it is the direct connection to the customer demand of this workstation which makes it possible to say this. And we're going to find a yellow zone, which is fairly weak here, and the green zone. This is an example where we've put in fairly little safety upstream of this work center. But this yellow tunnel with the green overhang being the capacity, as I have to put it, and this tunnel corresponding once again to the multi-level safety systems that exist downstream of this work center. And this instantly makes you think, am I drying up my safety, or am I moving into a really gray area where I could impact my customer? And that changes everything in the decision-making mindset, because you're not saying to yourself that your work center is 105% full, and then saying, well, I've made a decision, is it serious? No big deal. And finally, the last area that is gray, where I can put my capacities to work, I have the components to do it, but I know that I'm going to generate anticipation and overstock, and where, as a result, I am managing within my capacities, not saturation, which is actually rather ethereal information, but customer risks and overstock risks.
So indeed, as you have seen, we've had processes in place for a long time. Some customers have done their own development work, while for others, we've installed solutions and we've been able to see a certain number of results. The major impact in terms of results, I'll go back to the square I mentioned this morning, but the major impact is obviously on service level. That's the number one objective, which is that everyone works to contribute to the service level, but as you've just seen, it also avoids overstocking. Because at some point you can say to yourself in a very concrete way, if I do this now, I'm overstocking, and it's not going to go away straight away, obviously. As far as costs are concerned, we obviously have the cost of obsolescence that goes with inventory. We also try to get things done on time, so there's no need for express shipment. And that brings real peace of mind to the teams. So the aim isn't necessarily to make the teams as productive as possible, but it is at least to support strong growth. We've seen this with our customers. Some of them were doing 2 times over with the same teams because they're focusing on the right issues and they don't have to chase after data, trying to understand everything that's going on. Sustainability fits in with the other indicators quite obviously. There you go. We have implemented it in several sectors, so we say, so we're wondering, what is no chain planning eligible for? Obviously not for retail. As you'll have realized, there are no factories, so no chain planning isn't really relevant for retail. But I would tend to say that as soon as you have production and procurement planning with a few levels of bills of materials, and you have a few problems with suppliers, and lead times are longer than a day or 2, the concept applies. And in these examples, that's obviously the case.
A quadruple set of indicators.
There you go. So after that, there's the transformation that goes with it, because you understand that these concepts are not just tools. We're going to talk about this very quickly, but it's also a business transformation, which is quite significant, because where you had supply planners pressing buttons in the ERP saying, I'm validating, now they suddenly have to face something else, which is making decisions of a slightly more impactful nature. It's much more interesting, it's much more valuable, but it still requires training, change, and so on. And the same goes for load capacity planning, which is another way of thinking about the supply chain. So it's bound to have an impact in business terms. Having said that, the advantage is that we can put these tools in place fairly quickly so that we already have the first level, as Florian has shown you, which is the health of the supply chain, and then deploy department by department. Supply planners are a good target, and in the second phase, we can actually take steps, but it's not a complete process that we're going to do in 3 months. We'd be talking nonsense. It's going to take a bit of time, but we can get value quite quickly.
And perhaps a final technological point on our side, perhaps the last point, would be the genesis of the solution. It is more because we absolutely wanted to be able to have workable concepts, not to create yet another AI solution, I don't know what, but to have workable concepts that at some point can actually be implemented. So for more than 10 years, we have basically been developing a solution which is now entirely based on SAP, on HANA, and with a Fiori front end so that it can be integrated with our customers' SAP ERP systems, and at the same time offer the possibility that the concepts we have written about are not just nice ideas from a consultant, but something that is perfectly operable, and what's more, perfectly operable in the sense of having just one tool, which is SAP.
So much for the conclusion. We're open to questions, and we've got 10 minutes left.
I don't know if there are any hands up yet for questions. I do have one question, though, because it's true that when you listen to it, and it's because it's also fairly well explained, we think it's relatively simple, having the must do, the limit, etc. But I imagine that using the tool, which you say has taken you 10 years to develop, etc., it's much more complex to harmonize and synchronize the theoretical must do and the constraints, etc. I mean, I can't really measure the complexity here compared to what you're saying.
Well, of course, as Fabrice was saying, there's a real change in the mindset because, once again, when you're in an MRP logic, your customer is the N+1 level of the bill of materials or the downstream link in the distribution network. And here you're completely changing the logic where, in any case, everyone is directly connected to this customer demand. And that obviously requires a certain number of calculations and considerations. But of course, as we can see from the examples on the load capacity part, it's not the same way of doing the load capacity as the graph we're all used to seeing. It's not the same thought process. So it requires a certain amount of calculation, but if anything, it requires more of a change in the mindset, and that's what's fundamental. I have a different vision of the supply chain, a vision other than that of the MRP.
Perhaps to clarify, when we say it requires calculations, it's obviously not up to the users to do the calculations. So the calculations are already embedded in the solution, and they're not easy to do, because when you have several levels of bills of materials, being able to calculate an external must-do, a total must-do, taking into account all the levels, all the safeties, and so on, and even calculating the must-do, it represents a lot of calculation. But somehow the user doesn't see it, and that required a lot of R&D on our side. To give you an order of magnitude, we're talking about 300,000 lines of code. So it's not just a little Power BI. So there's a lot of calculation involved in all these signals, but for the user, the complexity, but I don't know if you can call it complexity, as Florian said, is to change his mindset. He's not going to ask himself how the must-do is calculated. It's done by the machine anyway.
And then, when we were talking about 10 years, it is because these are problems that we've been encountering for 10 years or so. And then little by little, we've come up with solutions for our customers. We've worked together. And after several years, we've managed to formalize and synthesize these concepts. And to say to ourselves, in fact, that these are the important elements, and that is the change in philosophy that Florian has just talked about.
Do we have any questions? Yes?
Otherwise, I will do the questions and answers at the same time. We talked earlier about these 4 signals. There are 2 must-do signals: ideal must-do, stock out must-do, and at the same time there are 2 can-do signals, the external can-do, which is there to say that if my internal capabilities were perfect, this is what my external suppliers project on the customer demand. And in some cases, we already have a stock out situation without adding any capacity constraint. And we have a second projection with the total can do, which includes capacity constraints, necessarily later, and which above all generally allows us to easily separate what comes from our suppliers and what comes from our internal capacities. Once again, with this vision, which is to honestly say that in today's supply chain, the vast majority of constraints comes from our suppliers, and we should be able to deal with them easily.
And if I also understand the question, it is a piece of information that we can naturally push to the customer, or that we push to the downstream supply chain, which is in charge of discussing with customers, managing orders, etc. And who has the information to say that this quantity, this order, we will deliver it 3 weeks late, and we know it very precisely because we do not have the supplies, etc. Therefore, this information of the can-do exists. It is up to those who are at the customer interface to tell it or not. But in any case, the information exists and it is correct.
Why not? Yes, and it depends on the sectors. If we take the aerospace sector, it's not necessary that we go to Boeing to tell them we're going to stop the fall. Really, it depends on the sectors. If we take a more retail sector, in the sense of dermocosmetics such as Sephora, Marionno, in any case, that's not what happens. Orders are regenerated every week. Each sector has its own particularity in, let's say, transparency towards the customer.
Another question from the audience. Question?
Otherwise, I can ask a question and I will answer it like this as well. Normally, there is always a question that arises, and I think that it must be burning some of your lips, but it is more by saying, but honestly, your thing increases the stocks for sure, because there is someone who will necessarily say, well, okay, everyone is connected to the customer demand, and there is, unfortunately, Jean-Claude, who is going to be late, or Marie-Renée, etc., etc. And at some point, the case that we were talking about earlier that ends up being late, we will say, you are a bit bad with your method, because at some point, the safety stock, well, all the others will continue to run on the customer demand and will deliver on time. So we are stupid. We knew that we were not going to make it because there was someone missing. So there are several answers to that. There is a simple one, which is if everyone is always waiting for everybody, we never end up delivering anything. And we often have that in supply chains saying, anyway, I don't put the capacities because the supplies aren't there. And for the procurement, I don't get excited about because anyway, the capacities aren't there. That's a simplistic answer, but it still has some true and common sense. And there's a second level of answer to that we haven't talked about here, but we're trying in the S&OP process. We're talking here, in fact, the whole point of what we're talking about is the signal. It's fundamental because we're talking about AI, about lots of things, etc., but the basis of supply chain is the signal. But what do we follow as a baseline? What we're trying to do in the node chain planning method is not to madly follow customer demand and don't ask yourself any questions, but more in the sense that we are able to compare what we must do and what we can do. So we are able to see that, for example, on certain items, we will be months and months behind schedule, and we are able at the same time to project overstocks. So what we call waiting for the last missing item. That is to say, we have plenty of stock that arrived on time, and we are waiting for the last item missing to release production. And there, we change the paradigm, because we say, you have a vision, a turnover that you would like to make. You have a vision of the overstocks that you have. And it is up to you, operational, to choose between I lower my demand, because I do not want overstock at the risk of never again obtaining this turnover there. Because we all know that as soon as we lower a signal, we always get less. Or do I maintain my demand and I assume the overstocks as such? So the method is not blindly saying I follow the customer demand, whatever the cost. It aims more at having an omniscient vision and saying the signal that I inject, I do it with full knowledge of the facts. And on the other hand, now everyone follows it because it is the one that I decided, and it is not local optimums, because the same goes for illustrating large supplies like in large aeronautical manufacturers. If we look closely at how supply chains behaves in complex diagrams, we will find factories that continue to follow customer demand and other factories that are telling themselves that they are implementing a plan that they can do. We end up with different choices in different parts in the chain, and we get the worst of both worlds. That is to say that as there is one that has decided not to do it, the other that has decided to do it gets nothing. Exactly. And we end up with both inventory excess and a bad service rate. So that was only here I was asking the question and answer. But this one is important because it could have naively suggested that we were going to permanently follow something that sent us towards worlds of overstock.
I'm bouncing back on the story of inventory, but it's true that there is another method that has taken on a bit of, let's say, importance in recent years. It's the DDMRP, that there we are really connected to demand, and we talk about buffer stock on a certain number of things. Is this the change in philosophy? What is it? It is pretty much clear with the MRP, but with the DDMRP, what is it?
So what we say quite often is that the DDMRP made the same general observation by saying that there is a vibration effect. But the first part on the limits of the MRP, it aimed to say, in fact, maybe that we need to dig a little deeper, because saying, okay, there is a bullwhip effect. It is the supply chain magazine that is there very well by saying, okay, there is a bullwhip effect, but if we dig a little deeper, what are the root causes of this bullwhip effect? And somewhere we took a slightly different path than the one of the DDMRP by saying to ourselves, when we write everything we write, we are saying that the main postulate is that the vibration does not come from customer demand at the very top. Yes, it vibrates a little, but the customer demands, the production rates of the A320 and so on, they do not change every 5 minutes either. Or the customer demand for this or that bag from this or that leather goods manufacturer does not change every 5 minutes. And that rather than freeing ourselves from this customer demand, we will connect to it and we will free ourselves from all the vibrations that can exist in an intermediate way. In that, it is different. And that is what we have been able to say at certain times. It is a bit the meaning of history. I think that there is an astronomical number of exhibitors around AI and forecasting. But what is the point of putting so much money into forecasting and AI to say that in the end, this signal on which we have worked so much is only used to size buffers? At some point, we want to say to ourselves that we must be connected to this demand, which is more accurate when we are in sectors where we know it, in the aerospace. To turn a blind eye regarding the way in which the Boeing FAL or Airbus will unfold, it can seem a bit surprising. And so we took a different approach, which is to say to ourselves, but we think that the vibrations do not come ex nihilo from the MRP, that we shouldn't keep anything. We think they come from these intermediate planning elements, which react, which interact with each other. Because I do not have the components, I plan, I change the signal, and then like the other, then there are interactions that are made in the bills of materials. Let's remove that and connect to the customer. And there we will leave some vibrations. But strictly speaking, most of the time, they are in the hands either of the customer, because he has forecasters at home, or of requests that can be more stable.
Okay. Are there any other questions in the room? Do we still have... Oh no, we don't have any more time. Oh no, I still had a very quick question. Because the fact of saying the signal will be shared within the company, it's not just the supply planner and so on, but does that mean that we're doing another process to find out who's going to speak? Is there a real dialogue between all these operations that all have the same information, or ultimately at the decision-making level, it won't change anything? Is there still a change in the way of approaching?
There is a real dialogue, because generally we find everyone who is connected to the customer demand. And so we have supply planners who are on an equal footing with planners, knowing very well what they owe them. And so it is not a discussion that is, let's say, immediately more focused, because the planner is not learning to procurement what he lacks to manufacture. They both know it. They know it in parallel. And so it changes the nature of the discussions in the sense that we do not need rituals that are not there to give information. The information already exists, and the rituals are there to go on more details.
It really aims at synchronizing everyone on the same signal and avoiding situation where, as we were saying, some factories that go to the right, factories that go to the left, and suppliers that go in a third direction.
And maybe to complete, I think it's an important subject. Jonathan mentioned it after COVID-19. That is to say, when we look at it, it's also all the more important when we start having tiers 1, tiers 2, etc. We were at suppliers of major leather goods, manufacturers at the time of post-COVID, and the time it took for the information to really be transcribed of China exploding, and then now China falling, and so on. It took months and months, and we're talking about what's it called, agility, stock policy, etc. No stock policy can overcome a 6-month signal delay. That's the whole point of no chain planning. It's saying how, in fact, we don't wait 6 months to know things, because once 6 months later we receive the increase in demand, there is no stock policy or capacity action that can resolve these issues.
Okay. Well, I think we'll conclude on that. Thank you very much, Fabrice, Florian, Jonathan. And otherwise, it is not very complicated to continue the debate because they are just there, no chain.